Hi everybody, today we're going to talk about the Cournot model. This is an oligopoly model, and we're going to talk about a specific case, which is the continuous case. Okay, the examples and information provided in this video is based on the book Teoría de juegos, aplicación, economía by Jorge Fernández Ruíz. In this video, I'm going to tell you about some intuitive interpretation about this model with graphs. And first of all, we have to set the assumption and characteristics of this model. So first we have that this is an oligopoly model with two firms. Okay, so we have only two firms, and these firms are going to compete in quantities. Also, they may have different costs. Of course, the cost could be between 0 and P, where P are the prices. Also, we don't have any fixed costs. So when a firm is not producing any quantity, the firm is not going to have any cost. Also, they can set any production quantity, set any set of positive numbers. So also prices are expressed as a linear function of the sum of production of both companies. So these are the assumptions. All the assumptions are very important. And also we have to set the strategy, the way in which we have to proceed to solve the model. So remember, our main objective or main target in this model is to find the Nash equilibrium. So first of all, we want to find this Nash equilibrium. And in order to find this equilibrium, we need to find the reaction functions, okay? So the Nash equilibrium is going to be localized where the two functions cross each other. And in order to find these reaction functions, we have to maximize profits. And to maximize profits, also we need to find the profit functions, okay? So let me show you this screen. Okay, at this screen, what we have are these two reaction functions. But first, before these functions, we have this demand curve. So first of all, we have to analyze this demand curve. Remember, in all the demand curves, we have two variables in each axis. For example, in the x-axis, we have quantities, and in the vertical axis, we have prices, okay? So for example, if the quantity in the market is about 4 units, the price is going to be around 2, okay? Also, if the quantity in all the market is 3 units, the price that allows to buy these 3 units in the market is going to be 3, okay? So in this horizontal axis, we have the sum of the quantities provided by the two firms. So let me give you an example. If one firm is producing 1 unit of some good and the other firm is producing 4 units, the sum of both productions is going to be 5. So the price that is fixed in order to reach this demand is going to be 1, okay? So at this price level, which is 1, 5 units of production are going to be demanded in the market, okay? So that is how this demand curve works. Okay, so now let me show you these two other curves. So these are the reaction functions. So we have one reaction function by each firm. For example, this curve, this line, is the reaction function for firm number 1, firm 1, and this other line is the reaction function for the firm number 2, the second firm, okay? So let's analyze each one of these two lines, okay? Well, first, we have this concept, reaction function, okay? So it's a function that is going to tell me how much quantity a certain firm should produce in order to react or respond to the production of the other firm. For example, for the first firm, we have this reaction function. And in this case, if the firm number 2 is going to produce 3 units of some good, the firm number 1 should produce something less than 1 unit. Something less than 1 unit in order to maximize their profits. Okay, so let me give you another example. If firm number 2 is going to produce 2 units, the firm number 1 has to produce something more than 1 unit, maybe 1.3 units. So this amount, 1.3 units, is the amount that allows firm number 1 to maximize its profits. Okay, so it's the same for all the other points in this line. So let me give you another example. If firm number 2 is going to produce 4 units, the firm number 1 should react producing around 0.3 maybe units of this good. So if firm number 1 produces this amount, firm number 1 is going to maximize their profits. Okay, so in the same way, in a relative same way, the firm number 2 has its own reaction function. Okay, so here we have the other reaction function. This function is for the firm number 2. At this function, we have a very similar way to interpret. Okay, so for example, if firm number 1 is producing 3 units of some good, the firm number 2 has to has to respond, producing something more than 1 unit. Okay, so remember, in these two axes, we are setting the quantities. Quantity of firm 1 produced by the firm 1 and quantity produced by the firm 2. Okay, so let me give you another example. If firm number 1 is going to produce 4 units of some good, firm number 2 should respond producing something less than 1 unit. So in order to maximize its profits, in a similar way, if firm number 1 produce 1 unit, firm number 2 should produce something more than 2 units. Okay. So we have a relative interesting characteristic of these two lines, which are the reaction functions. And the key characteristic in these two lines is that in all the line, along all the line, one specific characteristic is going to be observed. This characteristic is that in all the line, both firms are maximizing, or each firm is maximizing its profits. So in this reaction function for firm number 1, that firm is maximizing its profits. In this reaction function for firm number 2, that firm is maximizing its profits. So in all the line, along all the line, all that firm is maximizing its profits, okay? And this applies by each one of the two firms, okay? Let me give you an example. What happens if we want to produce firm 1 3 units and firm 2 3 units also? So if each firm is producing 3 units, each one, this point is lying outside both lines, outside both reaction functions. So in this case, no firm is maximizing its profits because it's not over each line. So it's a point that lies outside the lines. So no firm is maximizing profits. So it's not a good point for the firms. It's not a good strategy to produce 3 units of each item. Let me give you another example. At this point, for example, firm number 1 is producing 3 units, and firm number 2 is reacting, producing something more than 1 unit. And at this combination of strategies, firm number 2 is maximizing its profits, but it isn't the firm number 1. Why? Because this point lies outside of the reaction function of firm number 1. So at this point, firm number 2 is okay, but it isn't the firm number 1. So another example is this point. So at this point, firm number 1 is reacting, and is producing something like 0.4 units, while the firm number 2 is producing 4. So this is the combination 4 and 0.3, maybe 0.2. And at this point, the firm number 1 is on its reaction function over its reaction function. So firm number 1 is maximizing its profits, but it isn't the firm number 2. The firm number 2 is not maximizing profits because that firm is not over its line. Okay, so we have only one point where the two lines cross each other, which is this point. At this point, it's a common point between the two reaction functions, and at this point, both firms are maximizing their profits. So this is going to be the Nash equilibrium, which is, remember what is a Nash equilibrium? That is a combination of strategies where no firm, no player has incentives to implement another strategy. So that is the Nash equilibrium. It's this combination where given the strategy of the other player, my strategy is the best response, and at the same time, given my strategy, the response for the other player is that strategy that is playing. Okay, so that is a Nash equilibrium and is reached at this point. So all we have to do is just find these two lines and localize where the two lines are crossing each other in order to find the Nash equilibrium. So in order to find these reaction functions, we need to talk about the maximization of profits. So let me tell you something about these profits. So let me show you this 3D graph, this three-dimensional graph. So here we have this 3D graph, which is a graph of the profits of firm number 1. So this blue surface is just a graph of these profits for firm number 1. So remember, we have here in this axis the quantity produced by firm 1 in this horizontal axis, and in this vertical axis we have the amount produced, the quantity produced by firm number 2. So remember, red is for firm number 1 and green is going to be for firm number 2. Okay, and this blue axis is indicating the profits, okay, the profits of the firm number 1. So we have this surface. How have I construct and graphed this surface? So just check this equation. This equation is nothing else but the equation of profits, which is just the subtraction between two terms, total income, which is this first term, and the total cost, which is the second one. So total income minus total costs is going to be the profits. So in order to calculate total income, remember you have to multiply price times quantity, and price is given by this function. Why? Because remember, in this model, the price is just a linear combination of the two quantities produced by both firms, and is given by the demand equation. So this is the equation for price. this is the term for quantity. So price times quantity is going to be the total income. And if I subtract from total income the total cost, this is cost per unit, and these are the units. If we perform the subtraction, we're going to obtain the profits, okay? So this is the equation that allows to have this nice surface. And these parameters, A and B, are parameters that are given by the demand function. And I have set these parameters to be A equal to 7 and B equal to 1. So the only variables here are Y and X. And the C is this parameter per cost for firm number 1. And I have set this cost around 0.3. Okay, so we have this surface, okay? And now we have to analyze this surface in order to understand the profits and how the profits are maximized, and then how we could create these reaction functions. So these are the profits, okay? And let me tell you something about this. Firm number 2 is going to fix the quantity produced, okay? So for example, if firm number 2 fixed its amount produced around, I don't know, it could be 2, okay? Then the firm number 1 has this parable, okay? So we are going to obtain a parable when the firm number 2 is fixing the amount produced at some quantity level. Okay, here that level was 2. So if firm number 2 is producing 2 units, that means graphically that is sliding is this surface, and then we have this parable, okay? So when firm number 2 is producing 2 units, something around 2 units, firm number 1 is going to have this parable, and firm number 1 is going to maximize these profits, profits parable, at some level. For example, here at this point, we have the maximum point of the parable, and then the firm number 1 is willing to find this level to maximize their profits. And this level is reached by firm number 1 when firm number 1 is producing around something more than 2 units. For example, 2.2 maybe. So remember, when firm number 1 is producing 2.2 units, is maximizing their profits. And that happens when the firm number 2 is fixing their quantity at level of 2. But what happens if firm number 2 decides to fix the quantity produced at other level, for example, at this level of 3? Okay, let me fix the level 3. So what happens here? Okay, here what is happening is that now the firm number 1 has another different profit parable, and is going to be maximized at a different level. Maybe now it's going to be maximized when firm 1 is producing 2, maybe around 2. Okay, something like 2. Okay, and this depends on where the firm number 2 is going to fix the amount. Let me give you a third example. Consider the case when firm number 2 is producing a very low quantity, for example, a quantity around 1.5 or 1.6. So now firm number 1 has this parable, which is this one. And firm number 1 now is maximizing the parable maybe at this level, which is maybe 2.5, maybe 3, something like that. okay? And so what we have here is that the firm number 1 is going to maximize the profit at different levels depending on the amount fixed by the other firm, okay? So, so we have this situation, okay? So this plane, this gray plane is sliding this blue surface at different levels. Each slide is a level where the firm number 2 is fixing their amount produced. So at every different level, we have different parables for firm number 1, and then we have different levels of maximization for that parables. So this is a three-dimensional interpretation for this topic. And also we could interpret this in a two-dimensional plane, which is this. So here also we could have here the parabola for firm number 1. So let's fix the amount produced by firm number 2 on maybe something like 1 point, maybe something like 2. Let me fix on 2, okay? So here we have, and let me fix these costs in 1.5, okay? Let me fix this cost, 1.5, okay? So with costs for firm number 1 around 1.5, and in a level of production of 2 for the firm number 2, we have this parable for the firm number 1. And this parable is maximized at this level, something less than 2, okay? And this is the same parable that we could observe in the three-dimensional graph. So let's do the three-dimensional graph. Let me set the cost. Let me set 1.5, remember, that was the cost. Okay, and let me stop this slide at number 2. Okay, so we have the same parable, right? So this parable is nothing else than this parable, okay? So we are sliding this axis at number 2, okay? And we have this parable. So this parable is going to be maximized at something less than 2, which is confirmed by this graph. At something less than 2, the parable is maximized, okay? And of course, if we also change the slides not at 2, but maybe at number 4, the parable is maximized at something amount less than 1. So we could do the same here, just slide at the level 4. So we have this very small parable, okay? This parable is the same than this. And this parable is maximized at something less than 1, okay? So we have different levels of profit maximization depending on the different parables. And that is why we have different reaction functions. So let's go to this plane for the reaction function. Remember that at this plane we had in this horizontal axis quantity produced by firm 1, and at this vertical axis quantity produced by firm 2. So here we have these reaction functions, okay? And well, so now we have all the material necessary for end with these 2 lines, okay? And remember, these 2 lines are going to be crossed each other at the Nash equilibrium. And also another important characteristic is the following with the parable, by the way, here. This parable could exist at this at this part of the graph, of this first part. And also this parable could exist, could be plotted at this part of the graph with the negative numbers. And what happens in this at this part? What happens when the firm number 2 is producing a lot, so much that for the firm number 1, the profits are maximizing only if that firm produces a negative amount. What's happening here? Well, of course, we know that in economics, that makes no sense to produce a negative amount. So the best that the firm 1 could do in this situation is just don't produce, just produce an amount of 0. Why? Because we could not produce negative amounts. So the profit parable cannot be maximized because it's not possible to produce negative amounts. So the best that the firm 1 can do is just don't produce, just produce an amount of 0. Okay. And why is happening this? Because firm number 2 is producing a lot, so much that firm number 1 has literally no market to produce. Okay. Okay. So we have a bound where this firm number 2 has to be lowered in order to allow firm number 1 to produce some positive amount. And this bound is given by this expression, A minus C over B. So it's given by these parameters. So this bound is 5.5. So what happens if firm number 2 is producing 5.5? Let me fix this, 5.5. Okay, the parable is just that at this level, okay? The maximum point of the parable is just at the 0, okay? At this point. And if the firm number 2 is producing less than this, less than 5.5, we have the parable in the positive section of this graph, of this plane. But if the firm number 2 is producing more than 5.5, for example, 6, then we have the parable in this negative section, okay? So the limit is given by this, the limit is given by this expression, 5.5, okay? So remember, firm number 2 need not to produce, we need that firm number 2 don't produce more than 5.5 in order to firm 1 could obtain a positive amount and a positive profits, okay? And well, that was an interesting part of the parable. Okay, and now we have to these reaction functions, and of course here we have different Nash equilibriums. So let me put this animation. Okay, so we could observe that the Nash equilibrium is going to be localized in different points of this plane, depending on when the two lines cross each other, and it depends on the parameters about the costs, okay? So maybe we could find a Nash equilibrium that is localized at this point, for example. At this point, the firm number 1 has a cost of 1.3, and firm number 2 has a cost of 1.65. So in this case, in this situation, the Nash equilibrium is going to be reached at this point, where firm number 1 is producing 2 units and firm number 2 is producing something less than 2. That will be the Nash equilibrium, and it's okay. But what happens in situations, for example, like this? At this situation, the Nash equilibrium is at this part of the graph, at this negative part. So at this part, the firm number 1 is producing 2.5, around 2.5, and firm number 2 is producing minus 1.2, for example. So again, it's not possible in economics to produce a negative amounts. So firm number 2 could not produce minus 1.2. Okay, so the best that firm 2 could do is just don't produce anything, produce an amount of 0. Okay, so here we have an interesting issue here. When we localize the Nash equilibrium at these sections, at these parts, we couldn't establish that the Nash equilibrium is localized when the two lines are crossing each other. Why? Because it's not possible to produce a negative amount, okay? And when happens this? When this is going to happen? Well, we have now this expression, A plus C divided by 2, which is 4.95 in this case. And that means that the cost of the firm number 2 has to be lower than this parameter. So let me check here. The cost is higher, but what happens is the cost is lower than this parameter, which is 4.95. So for example, what about the cost is 3.1. 3.1 is less than 4.95. At this point, we have a positive amount of production and a very natural Nash equilibrium here. But what happens as we approximate to this limit, to this bound, 4.95? So let me approximate to that, 4.95, 4.95, okay? Here we have the limit. At this level of cost, firm number 2 is going to produce anything, an amount of 0. And firm number 1 is going to produce 2, an amount of 2. And what happens as we diminish the cost level of firm number 2? For example, a level of 4. This line is going up, right? This reaction function is going up, so the Nash equilibrium is localizing in a point up, in the up section. Let me reduce even more these costs. If we fix this cost at level of 2, again, we have a Nash equilibrium in this positive section, and the same if we continue reducing, okay? So where the Nash equilibrium is going to be localized, it depends on if this cost of firm number 2 is lower than this bound, okay, 4.95. Okay. If it is lower, it's okay. The Nash equilibrium is localized in a positive amount for two firms. But if this cost is sufficient higher to be greater than this bound, the Nash equilibrium is going to be localized at this part. And firm number 2 is going to produce a 0 amount, and all the amount in the market is going to be to produce it by the firm 1. And what is this? This is a monopoly. So this is a very important conclusion for this Cournot model, that if the costs for firm number 2 are very, very high, this will cause that this firm is going not to operate in the market, and only one firm, that firm with the lower costs, is going to be the only firm that is going to operate in this market, okay? So in this case, we will have a monopoly. Why? Because firm number 2 has very high cost per unit, okay? So for that firm, it's not worth producing anything, and that would be a monopoly. So this bound is very important, because this determines if the market will end with a monopoly in the Nash equilibrium, or if it is not, okay? Well, so I think that's all for this video. I hope you will find useful this video. and see you in the next time.